So it talks about the real estate office, the layout of all the receptacles on the light. Now, Jeff, what I would like you guys to do is use this as an example. I don't like the way they look how they label the panel. It says brand circuit and panel. Just give it a unique name. You know, unlike we assign a unique name, so that would be, for example, panel number one, or so they didn't name the panels. So they have multiple panels. I don't know if you see there's an elevator, there's elevator panel, there's baseboard panel. So it's really hard to know which panel is doing what, for the most part. But if you can tell if the panel is in the area, so it's going to be most likely, here's a panel here. So what do you think this panel in this area is going to be doing? It's going to be feeding all the receptacles and all the lights and everything else in this area. They don't have lighting panels or receptacle panels like we do in our projects. So here's what this chapter basically is all about, my friends. Let me just quick here run through it. It's working drawing upper level. So that's what it is. It talks about tabulating the material and estimating. Jeff, what we're going to do for estimating is we're going to have 6 weeks estimating, guys. We'll talk about the whole material. So tabulate material requirement to install electrical systems, install the electrical water heaters, disadvantages between single-phase and three-phase supply system. I can tell you right now, you are a fool if you have a three-phase system and you use a single-phase system. You have a three-phase system, what do? Three-phase panels, everything's three-phase. Can I have thumbs up, Chad? If you have a three-phase system. Huh? The estimating is going to be next semester. Yeah, when we take off an estimating next semester. Special systems in the floor. In the office, guys, I'm going to show you in the insurance office, they have in-floor receptacles in the center of the office. Feel free to look at them. Special raceways installed in 2 exterior walls, provide electric and communication for the area. So this is just taking that particular layout, Jeff, and talking about it, right? That makes sense? In the insurance office, we have computer room. What they did, they have special luminaires in the computer room so they can cuts on the glare. Receptional area, we have also a combination of lighting system to provide really nice look. You can imagine where the reception area are going to have a nicer look than in certain offices. So again, they're talking about the lighting and the power in the insurance office. Computer room, you can imagine why in the computer room, there's servers. So here's what you need to do in the computer room. Good practice. Number 1, you need to have surge protection. Anybody knows what surge protection computer room? You have servers there. You don't want to burn them. Expensive. Number 2, grounding system. You have to have a good grounding system because you don't want to burn your server. Number 3, a different neutral. Why do you think they pull in a computer room where the servers are? We pull an extra neutral because of harmonics. You guys are familiar with that one. How about, look at this. Luminaire lenses that cuts on the glare on the computer screen has been specified. So if you have a computer room with servers and so forth, and especially screens, you use lenses. We did the same thing with louvers, guys, that cuts on the glare, so makes it easier to read through the screen. Now the technology is probably ahead of them. 2 grounds. They have also insulated ground because of interference. They don't want to interfere with these servers, so they put an insulated ground. Grounding conductor, an insulated grounding conductor. Receptacles are insulated ground receptacles, insulated grounding conductor with them. And the insulated ground goes all the way to the surface. So what they do, as we all know, guys, if you have sensitive electronic equipment, as in servers, you installed an insulated grounding receptacle where the yoke is isolated from the slot that grounds, and you have an insulated grounding conductor, number 12, that goes through the panel all the way to the surface. Who cares? They use them to minimize the interference with the electrical equipment. Still, who cares? If you don't care about typing $10,000 and end up $10 million, I don't know what you care about anything else. So corruption of data. The most important thing, minimize the corruption of data. Surge protection. Why do we think surge protection we have in the computer room? Lightning and other surges protect the equipment. Neutral, possible conductor overheat because of neutral with every phase. Why? You guys remember neutral with every phase? Why? Minimize the harmonic effect so you don't overload the neutral. So that's what they're talking about here in the insurance office. Then they talk about takeoff, material takeoff. Material takeoff, guys, you're going to be doing it with me next quarter. We will be taking the 3 projects that you designed. We will do a hands-on on 1 project and computer takeoff and estimating on the 2 other projects. So that they're saying is journeymen like my friends here, Jeff and Darren, need to be able to come up with a list of the material that need to be installed in the system. We're not going to talk about this one at this time. Some tips, understand the system, take off notes and so forth, but we'll talk about it when the time comes. In this area, Jamie, read this one. Beauty what?
Salon.
Salon. I always want to call it saloon. Beauty salon.
Yeah,
Beauty salon. Connection to, we have a water heater. As you imagine, if it's salon, what do you do there? They groom hair and all this stuff. So they need a lot of water. Water heater. We have laundry, small laundry, lights and so forth. Water heater, circuit. Beauty salon supplied by the electrical. There's an electrical heater that heats the water. Here's the layout. We'll talk about the layout in a second here. A few things about the water heater. This is really nice calculation if you guys just look at it. Here's they bought this amount of water heater. Here's the voltage. I want to remind you, Jeff and Jeremy, my friend, is single phase, 208 single phase. Can I have 208 single phase? Yeah, 2 hots. So when you size, here's the watts for the heater. It's an appliance. When you size the service for it, you just divide it by the voltage. No 1.73, right? 13.8. Then you multiply by 1.25 continuous load. You get this amount of amps. Because it's an appliance, to size the overcome protection device, you multiply by 1.5. Do you guys remember that 1.5? We said that one. See how it repeats itself when things are repeat itself. So here's the overcome protection device size. So long story short, you end up with number 30 amp tied to a number 10 conductor to feed this water heater that burns at 2.8 for the salon. Okay, here's how it looks like. Let me see. Go back. Here's how it looks like. This is actually a water heater circuit and an internal circuits. I don't know if this looks like a 3-phase here. 3-phase with different circuit. We'll get back into that one, guys. In the same location, we have a washer and a dryer combination. This is how they size it. It's a 208 single phase. 125 the full load current. Look at the full load current here, guys, and then a 21. So you end up with a 25 amp. I'm gonna go one more time. Take the full load current of it by dividing the 4,000 by 208. You multiply by 1.25. You get 19.2. So long story short, you end up with the 21 amps and 25. So number 25 amp overcome protection device with number 10 conductor tied to the combination washer dryer. Anybody have seen combination washer dryer? Small washer dryer combo. So you take the full load amp, multiply by 1.25 size your conductor size overcome protection device for the most part. Real estate office. We have small storage areas. The distribution panel located in the small storage area. Control panel for the elevator. I'll show you in a second. Elevator is green. Operating elevator room. There's no elevator room, so it's just an elevator panel. Toilet. In the toilets, what they did in the toilets, guys, they have handicapped accessible. They have under counter water heaters. They have wall mounted space heaters. Occupancy sensors to control the fans. Look at this is exactly what we did. An occupancy sensor to control the fan and the light in the area. Does that make sense? That's exactly what you guys are doing. And all these, since their bathrooms are used by all the tenants, bathrooms and hallways, guys, are fit from the house panel, called house panel. Can I get you guys to give me a thumbs up? We understand that we have another project going on in this book, which is 2-story building and multi-tenant building. The common areas fit from the panel, the owner panel. Everything else fit from their own panel, right? Remember what we went through it? So that's what the book is basically tailoring it. Okay, so let me go and see if I can get some zoom into. So that's it basically. That's the. So if you guys look at, I want to start. If you guys don't mind me zooming a little bit in Salon here, and I don't know if you can see. I don't want you guys to remember. Can you guys see the quad that they're putting on this wall. So I have GFCI quad, all of them are fed 4, 5, 6. They brought a circuit to every quad here. Can you guys see them? Do you see all their lights, E lights and F lights? So this is just going through the smoke detectors here and going through the switching for all the E lights. So they're going through the switching mechanism as well as the light. Here's a bunch of other receptacles here. So who cares? Here's my question for who cares. Jeff, if you're faced with a project that you have a beauty salon that you need to design, and you have no idea how to lay out the outlets, wouldn't that be a good example? Well, I saw one, it's already laid out. Would that be a good template to start with? Cool. So that's what this is all about, guys. If you go to, at the end of your book, guys, start at page 509, it tells you what each circuit is feeding. They have the circuit directory for all these circuits and what each circuit is feeding what. So without further ado, here is it over panels, service and feeders, insurance office, bakery. Okay, for example, if I'm looking at the beauty salon and I'm looking at right here, panel. So if I look at page circuit 4, if you guys look at circuit 4, it says receptacle sales. Circuit 5 and circuit 6, it says receptacle cash register, receptacle work area. I'm looking, guys, right here at page 507, have the panel directory for all the panels in this project. It tells you what each circuit is doing, because I have no idea what circuit number 4 is doing. Can I have thumbs up, Chad? We know how to understand these directories. As a matter of fact, Darren, you are generating these directories for me. So what do I want you guys to do from this project? Please review it, get ideas how to do them. If you look at the directory, it gives you ideas if you are faced with a project, a multi-tenant building like this, because our building is single tenant. Remember, it's an office for one tenant. This is a multi-tenant. How do you design a multi-tenant commercial building? Here's an example. Light and receptacle, low voltage. It's another example. Cool. So if you guys look at this circuit right here, it says washer and dryer. Can you guys see right in here? They have a special receptacle for a circuit 11 and 13, 208 for washer and dryer. So that's basically it in terms of, let me see what circuit 10 is doing. Circuit 10, if you look at circuit 10, 9, it says here 9 through 14, it's disposal. Disposal, circuit 10. No, this is in the bakery. I'm in the wrong one. I'm sorry. 505. 505. I was on the wrong one. I apologize. 501. So circuit number 10 is receptacle east and west wall. Can you guys see that? And 6, 7, and 8. Then what was 6, 7, and 8 then? I was on the wrong panel. Thank you. So this is 4, 5, 6. What's 4, 5, 6? 4, 5, and 6, they are receptacle station 1, station 2, station 3. That's where they're going to groom you, the stations. Cool. Any comments, any questions, guys, about the layout of the receptacles and the lights? Layout of the receptacles and the lights in this area. Now, if you go to the real estate, let's go to the real estate here. So what was the real estate here? Help me here, Tammy. Bakery, insurance office, drugstore, real estate. 513. Thank you. 513. Okay, 513. This is real estate worksheet, circuits. Okay, so if you look at if you don't know what circuit is, I have a circuit 4 here. What does circuit 4 do? Circuit 4 says water heater. They have a little water heater and have an outlet for it, guys, right in here to feed it. There's also, what is circuit number 19 and 23, 19, 23. These are coming from a different, that's for the elevator. That's for the elevator control panels, not from here, from the owner equipment. Okay, so that's basically what this is. I would like you guys to go to circuit number 13 through 17, elevator. That will be the owner panel. Owner panel. If you go to owner panel, circuit 13 through 17, Jeff, it says elevator. That's where your three-phase elevator is going to be powered from this power outlet. Any question, guys, about this chapter? So please, I can't emphasize the word please, Joe, my friend. Look at this. Again, you can't, but just by looking here, you have no idea what things are. So in order to understand your fully Zach, you have to look at the directory here, okay? And this is what I would like you guys to look at the directory, because guess what? Not next week, the week after, you're going to be generating this directory from Revit for me. When you set a name for the circuit, I want a unique identifiable name. It's not enough to say receptacle circuit, which part. So if you look at these, Jamie, it will give you an idea how to label your directory. I know we did it with residential, so it's not a big deal for you. Okay, so that's basically it in terms of here. If you guys look at one more thing, I'm going to go here, is that the insurance. So here's the real estate office. This is the insurance office. Yep, insurance office. They said there's a couple of, okay, here's the insurance office. I think this is your multi-circuit number 9 and 13. Let's go to the insurance office and which page is it, Jeremy? Real estate, page what? Beauty salon. Okay, beauty salon. So insurance office, it's page 509. 509. If you guys look at circuit 9, what the heck is circuit 9? Circuit 9 is actually giving me a computer receptacle. So can you see why circuit 9 says IG, isolated ground receptacle here? These are all isolated ground receptacle. These 3 are in circuit 9. These 3 circuit 11. These 3 are circuit 13. These are where your office servers are going to be located. Can I have thumbs up, Chad? We fully understand how to read this, baby. So that's basically what this is. I want to see a circuit. Can you guys see where it says, look at this here. It says 4, 6, and 8. What the heck is 4, 6, and 8 here? There's a circuit going 4, 6, and 8. 4, 6, and 8 is multi-outlet raceway, multi-outlet raceway, multi-outlet raceway, all the way. They're having a multi-outlet ampli 4, 6, 8, 5, 7, and 9. These are all multi-outlet. So Zach, my friend, if you can see 5 and 7 here, 5 through 5, 7 are multi-outlet. Multi-outlet. Everybody can see that, guys? That's how they represent the multi-outlet. It would be nice if they draw something here. That's your multi-outlet assembly. Any comments, any questions? Any comments, any questions? They didn't say anything about the lighting system here, guys, but we'll talk about lighting as we move on to, okay, so here's your light, your switches, high voltage. All this stuff is high voltage switches. Bathrooms. If you look at, I'm going to go to the female bathroom so I can get your attention here. Female bathroom, let's go see circuit 7 through 7 and 9. What do you guys think? Space heater here. We have circuit 2 is light. Circuit 5 is a receptacle, right? Typical, exactly what we did. There's an exhaust fan right here that's fed with the light. And there's a smoke detector, I believe, as a smoke detector here. So that's basically it, what they have in, there's an emergency light. Can you guys see that? That's what you're going to do with me. They have an emergency light, emergency light in the bathroom. Occupancy sensor right here. They have an occupancy sensor switch, so I turn the light on and off as well as the fan. Can I get you guys to understand my OC will control all the lights here as well as the fan. You walk in, not you, Zach, your girlfriend will walk in here. The fan will go on and the light will go on. It stays on for 30 minutes or 15 minutes and turns off. I have a receptacle dedicated circuit for it, as well as a heater, space heater. I think 5 is doing, what is 5 doing? 5 is, it looks like 5, where are we here? We're in the bathroom. So it's owner, this should be in the owner panel. Owner panel 5 is called water heater. Second toilet. Actually, this one 5 is for water heater, and the GFCI, I assume they don't say what the circuit is. GFCI, I assume they're going to feed it from the same circuit, lighting circuit. Am I missing anything here? Anybody can see the GFCI in the owner panel? Oh, they're feeding it. Would it be a good idea to put the receptacles on one GFCI circuit? Absolutely. I don't see where the receptacle is fed from. Okay, so I have a water heater here, and a space heater, and a GFCI and receptacle. Most likely will be fed from a dedicated circuit. Same thing in the male's bathroom. Okay, so that's just an overview, guys, of the power layout and a little bit of circuiting. Any comments, any questions? Any comments, any questions? Well, my hope, Joe, my friend, is this, between this project and what you guys are doing with me, give you different ideas of design. The first time I designed a substation, Joe, my supervisor, Keith Erkson, he grabbed that thick 3 projects, put them in front of my desk the first day I was there. And he said, Chad, take these home and study them. My first day at work. So took the substation that they already did, studied them. Why do you think he did that? Example, you don't need to reinvent the wheel. The wheel have been reinvented. So look what other smarter people than you have done, Chad, and try to do something better, right? That's basically what the design is all about. Here's an example, a good example, now do better. When you go to design a multi-tenant building like this, Joe, my friend, or Jeff, or Jamie, and you have no idea how to start, here's a template for you. Start there, go to the owner, say, do you guys like what we're doing? You look much more intelligent if you have a blueprint in front of you, with you, than if you say, what do you guys want me to do? Don't you think so? When you go with a blueprint in the front of your drawing and say, here's what I think you guys should have. What do you think? Does that meet your needs? You look much more intelligent, and you justify why they should pay your company $5,000 or $10,000 to design the system. It's all about examples. I don't have an example for a hospital for you guys. You go work in a company that has hospital. The first thing you ask them is about, do you guys have a design project I can have a blueprint so I can look at it? And then try to do the same, if not better. We all start the same way. That's why we threw all this stuff, guys, at you, not to punish you. Okay, any comments, any questions? Any comments, any questions? Aaron, my friend, does it make sense? Yes or no? Now, is this the only way? Should I turn this into circuit 2 or 3? Who cares? I mean, circuit 2 now. Would it be different if it was circuit 1? No. If I move the receptacle slightly to this side or to this side, would it make a big difference? No. So who's going to decide that this receptacle sit here? We think it's the owner wants it here. Then it would be really nice to discuss it with the owner and say, how do you going to lay out your furniture? If they have no idea, here's one way. Remember, 6-foot extension cord can get you covered anywhere here. So, can you guys see how they throw a receptacle on every wall? Almost one receptacle on every wall. That's kind of the rule when you do commercial building. Thumbs up, Chad, we got it? Okay. Rest of the day, please, if you have time, I want you to print 22 by 34 complete lighting system, circuited, switched, and tagged. You have time, please jump in and start doing the outside light. The outside light, same way. Thank you, guys.